So here's the easiest way that I've personally found to do these type of problems. So now we're actually going to start doing some work. And it's based off of some reformulation of the equations that we've already been given. So this works particularly for big O, and it could be redone for minor adjustments if you need to do big omega, but this is focusing on big O. And that's based off the equation that we've already been given. F of n can be less than or equal to our constant times our g of n. Now, when we reformulate that, we actually, to determine c, it's just kind of a jury-rigged around here on figuring out how we can get c by itself. Now, we use c by itself to, well, let's do the rest of it here, is that for our threshold, or n naught, we're going to go ahead and determine it as 1. So remember, 1 is that first piece of data, and then it starts acting normally. That's what we're going to use by default for a threshold. And it makes sense to at least start at 1. Now, to solve for c, we're going to use that equation that we were just talking about, which is just, again, this just reformulated to have c by itself. That's it. Now, we're going to assume that n, which is the actual number of pieces of data, is going to be greater than 1. And that makes sense because, again, it didn't run with anything less than 1. But that's important. N is going to be greater than 1 is important since that implies that, and notice that the signs are just reversed here, 1 is less than the number of data pieces that's going to be in there, n is less than n squared. The rest of the things you probably already know already, let's put it that way. But we're going to use that, and I switched the signs here on purpose for a moment, so bear with me on that part. So here's our first problem. Now remember, we actually want a line that is either equal to or above what we're about to do. And that is, our f of n is equal to n squared plus 2n plus 1. Is it big O of n squared? Now remember, n squared can be equal to or greater. The other parts I want you to look at real quick is in the equation of f of n, which I'm broken down and parsed into f of n and then the g of n here, is that our f of n, what is the highest term in that equation? And that's the n squared. Now remember, n squared means that if we did this by itself in the different parts of n squared, 2n, and plus 1, which one's going to take off as more and more n's are added? And that's obviously going to be the n squared. The 2n and the 1, they're just chicken whatever. They're not really going to make the equation go up too much as n squared. So we're going to use that to our ability too. So once we figure out that we're going to use n is equal to 1 and then assume that we're going to have data pieces that are going to be greater than 1 here, what we did was we reformulated, like we showed in that previous portion here, is that here's our f of n and g of n. We go ahead and plug in the values. They came right from what's being circled right now. But here's the deal. I am trying to solve for the constant first. I'm going to use that here in a minute. So I'm going to change up this algorithm just a little bit. I don't mind adding to it, because we're looking for a line that's above it, to go ahead and try to knock out common like terms. So you're going to see this equation right here. Most of it's the same, but I added a couple of n's to it, or n squareds to it, just to frankly make it that we can go ahead and cancel things out and go ahead and get our 4 for our constant. Again, I'll use that constant here in a moment. Now that we've done that, let's break things down. Is this equation, which was our f of n, and this was our constant plus our g of n, do they work out? Again, remember, the only thing we're looking for is it less than or, greater than or equal to, is g of n, is this one going to be greater than our f of n? Now remember, the only terms we changed were really behind here. It really didn't matter much. What was the highest term in this one? Was n squared. So what we're going to do is we're going to look at each part. So I'm going to circle things here. Is n squared less than or equal to n squared? Yep. Is 2 of n less than or equal to 2 of n squared? And the answer is yep. Is 1 less than or equal to n squared? The answer is yes. So it's all going to work out with our g of n. Again, remember, really, we didn't do too much. N squared was already there. We just added a constant of 4. Because remember, when you add all of these up, that is equal to 4n squared. Same idea. That's all we did was add a constant to it, and it worked out. And this happens to be all true, and so n squared plus 2n plus 1 is big O of n squared, because it is that equation, but when we have our constant 4n squared plus whenever n is greater than 1. So let's see how that looks like on a chart, though. Here's our graph. Notice we've graphed both g of n and f of n, and notice where they meet. Geez, right at 4. I wonder where that came from. But also notice not just the y value, but the x value, which really is our n in our graph here, is the data, where that's going to meet. So this just proves exactly what you and I just worked on. And every graph really should kind of come out like this. So here's another problem. Same idea, same steps. The equation's obviously a little different. So show that f of n is 3 of n plus 7, and that is big O of n. Now remember, the breakdown of f of n is being highlighted, and g of n is being highlighted right now. So that's where you also have it in this equation, exactly the same spot. So what am I going to do? I'm going to try to cancel out all the n's. So I'm going to add an n to 7n. Again, we want it bigger anyway. So, and then, again, n is the default term anyway in that whole equation. It's really not going to matter much if we add another n to it. N was already there. So we're going to add those two together, get our 10n, and get our constant of 10, which again, as you can see, I'm going to use here in a moment. So now we check the parts. Is 3 of n less than or equal to 3n? Yeah. Is 7 less than or equal to 7n? Now remember, n's going to be greater than 1. So it's just at least going to be equal, if not greater. So that's going to work out. So 3 of n plus 7 is going to be big O of n, because 3 of n plus 7 is less than 10n, wherever n is greater than 1. And again, let's show you the chart. So again, here's the chart. We're going to go ahead and graph g of n. And remember, g of n needs to be greater than f of n eventually, and that's exactly what happens. Again, our constant was 10, g exactly where do they meet, and again our n was equal to 1. So notice we're just proving the same thing again by just graphing it out once we solve it.